Welcome. In this video, we will learn about detecting edges of an object. Edge detection is one of the most popular techniques in computer vision. It is used as a pre-processing step in many applications. Let's look at how to use different edge detector to detect edges in the input image. So let's open my directory which contains the file. So here is chair.jpg, which is sample image on which we will try. So here is the Python script, that is edgedetector.py. Before moving further, let me demonstrate this script, what end results it gives. So let's open terminal, run the command as python edge_detector.py and hit enter. Now let's see, it requires image to be input to run this Python script. So for that, now we'll write python edgedetector.py chair.jpg. We'll hit enter. You'll see I got an image here. This one is Laplacian. This one is Sobel vertical, Sobel horizontal. So this is the image which was the input. So here is horizontal Sobel edge detector output. Note how detected lines tend to be vertical. This is due to the fact it's horizontal edge detector and it tends to detect changes in this direction. And the another vertical Sobel edge detector output looks like the following image. So this is one, and the Laplacian edge detector output. Canny edge detector detects all the edges nicely in this following image. You can observe that. So Canny edge detector is one of the most accurate and clean image in these all three. So now let's get back to the Python script and see what all program one has to write to make this happen. By just seeing the output, you should get that the image is in black and white format, that is grayscale. So first we have to make it grayscale. Let me open the Python script. I'm just mentioning from top to bottom because if I explain it again and again, you will remember it forever. So the first one is input. As far as this module provides access to some variables used or maintained by interpreter and to functions that interact strongly with the interpreter. Import CV2. CV2 is a popular library for computer vision which I already discussed installation and in depth in previous video, which is basically used in object detection and tracking. Now next, import NumPy as NP. Import the NumPy module. It is an open source extension module for Python which provides fast pre-compiled function for mathematical and numerical routines. So the first thing what we have to do is convert the image into grayscale. So first I will define one argument for passing my image file, that is taking input, that is input underscore file dot sys dot argv inside braces 1. Now let's load the input image chair.jpg and convert it to grayscale, that is img equals to cv2 imread input file cv2 imread underscore grayscale. So here we are loading the image and converting it to grayscale. Now let's extract the height and width of the image. So height, that is h, w equals to image dot shape. So the first step is done. Next, let's implement all those filters which we saw, that is Sobel horizontal, Sobel vertical, Laplacian and Canny. So before that, I would like to talk in brief about Sobel filter. Sobel filter is a type of edge detector that uses 3x3 kernel to detect horizontal and vertical edges separately and run the vertical Sobel detector. So the syntax is pretty much simple. Sobel underscore horizontal equals to cv2 Sobel mg image cv2.cv64f key size equals to 5. And next the vertical, subal underscore vertical equals to cv2 subal image cv2.cv 64f01 key size equals to 5. So this one will just convert your grayscale image into subal horizontal and subal vertical. These all are included in our OpenCV library. So next, Laplacian edge detector that detects edges in both directions. Laplacian equal to cv2.Laplacian mg cv2.cv underscore 64f. And next, Canny equals to cv2.Canny mg 50 to 40. And next, Canny edge detector outperform all of them because of the way it treats the problem. It is a multi-stage process and it uses hysteresis to come up with the clean edges. Canny equals to cv2.Canny img 50 to 40. So now let's print the original image here, that is cv2.imshow original.img, that is the original image which was the input. So next, display all the output images for horizontal and vertical, that is cv2 imshow subal horizontal, comma subal underscore horizontal, and the same way for subal vertical. Now next, let's display the Laplacian image and Canny image in the same way cv2 imshow Laplacian, comma Laplacian and Canny. Now after that, if you just leave it, the image will show up and just close after execution of the program. So we want images to stay there so that we can observe and study. To wait the images, we have to just type cv2.wait key. So let's move to output now, which you have already seen. Anyhow, we'll see again the output. Now let's run the command python edge underscore detector.py and the image name, that is chair. Here you can see the original input image, the horizontal subal edge detector, and the vertical one. After that, Laplacian edge detector output and the Canny edge, which is very much clean. So this is how detection of edges using OpenCV is being done. If you have any doubts, please do watch the video again. Yet you have still doubts, then post in Q&A section. I will reply them. Thank you for watching this video.